In this video, we'll be going through the setup of a routine type within the application. Within the routine type, the user has the ability to set up templates that can be used to share generic procedures. These templates can be used to set up routines for instruments that share similar or even the same values. You can create a predefined list of generic routine type templates, which will allow a user to quickly set up a new instrument and allocate routines. In each routine, you can have a certain amount of information. You can put in a name, a description for the routine type, and the interval which is used in the scheduling of an instrument with a status of open maintenance. A user can also set the priority and the estimated time, which can be very beneficial for resource planning, recording and reporting on estimated time versus actual time spent carrying out the work. The next date update option allows the user to select the way that a routine's next due date will be calculated. Standard means that the calibration will update as normal. An example of this would be that an annual calibration would happen on the same date every year. The issued and conducted by options will use either the issued or conducted dates and interval to calculate the next dates. The due in the future value is the amount of days before a routine will appear on the work screen relative to the next date. We can also set up the routine so that it is complete when the technician is finished entering calibration results. We can do this by clicking the completed entry checkbox. If this is not selected, then the work order for that routine will need to be verified by a different user in order to complete it. If we want to create automated deviations, we can do this by selecting the critical checkbox. This will result in an automated email being sent out to the email address listed for the company the routine is associated to. We can then associate SOPs, different safety permits that might be needed, and the tasks that we can predefine with regards to maintenance or inspection. The order that the tasks appear in can be set using the up or down buttons, or by clicking and dragging the task to another location. If an SOP is linked to the document or a URL, then it can be viewed from the work screen. This can be done at the issue, enter, and verify stages of the work order, and also from the historical records of the work history screen. The Values tab is only enabled when Loop Calibration Sheet or Instrument Calibration Sheet cert types are selected. So now to the Routine Type Values tab. In this screen, we can set up values for routines to be downloaded to a calibrator, and also routines for manual entry. The resolution field is used to set the amount of decimal places for the values on the screen, and the cal points sets the amount of rows in the values grid, which can be up to a maximum of 99. The tolerance type consists of units, meaning that the tolerance used will be a unit value. Percentage range will calculate the tolerance value as a percentage of the range. For example, if a percentage range tolerance is plus or minus 1 with an output range of 16 milliamps, the unit value will be plus or minus 0.16 milliamps. Percentage test point or percentage reading will calculate the tolerance value based on the reading value. This will change as the required reading changes. An example of this is if the tolerance is plus or minus 1 for a reading of 50. This would lead to a unit tolerance value of plus or minus 0.5. After entering the first tolerance in the grid, the rest will pre-populate with the same value. You can, however, also use different tolerances for each calibration point, as I am doing here. Checking the point naming or unit naming checkboxes will also add 2 additional columns to the values grid. These 2 columns will then also change the printed calibration sheet format to accommodate the extra grid columns. These extra columns are very useful if you want to have different parameters in the same values grid. For process instruments, this might be combining humidity and temperature, and identifying raising and falling values. For mechanical calibrations, this might be combining the internal, external, and depth readings of vernier caliper calibrations. From the Values tab, we can also set up defaults for the input ranges and units. The output ranges will default to the same as the input ranges, or we can check the output checkbox and apply a different output range and units. You can then decide to display single or multiple tolerance values by selecting the tolerance plus or minus checkbox. There is also an option to have a second tolerance level using the adjust level checkbox. This can be used to alert the technician when they should make an adjustment. The set points for a routine are a set of desired values, but can be different when the technician is entering the results of the calibration. An example of this would be that your set point is 70 degrees Celsius with a tolerance of plus or minus 1. You then enter a reference input of 65 degrees Celsius and also an instrument reading value of 65 degrees Celsius, and this will result in an error of 0. So this brings us to the end of this tutorial. Thanks for watching this video, and be sure to check out our other tutorials at www.compucalsolutions.com.